All right, welcome everyone. We'll go ahead and get rolling here. We've got a few more people here hopping on here, but it's all good. We can go ahead and get rolling here. So welcome to our webinar. Our webinar today is about safeguarding pipelines, strategies against natural man-made threats. And what I'm going to start with first are introductions here. So to start it off here, I'll let Justin introduce himself. So Justin, go ahead and say
All right.
hi.
Hey, everybody. I'm Justin Oliveira. I'm the co-founder and CEO of Boston Geospatial.
Yep, great. And I'm Matthew Abbitt. I'm the Chief Product Officer here at Irth Solutions and been in the industry for years and actually see some people that I've met in person before on this webinar. So it's great to see some familiar faces here. So let's go ahead and get started here on the actual topic here. So one of the things that we do at Irth Solutions is we talk to a lot of customers and we go around and speaking to many people in the industry as a whole. And there was a common theme that kept popping up. So we're going to start with an actual problem statement of what we kept hearing. And this is the problem that our customers kept coming to us for and asking us to address with a particular solution. So one of the major problems here is that conditions are constantly changing around the assets in the field. So all the pipelines that are out there in the field, things like slope, seismic activity, fire, soil moisture, the weather, also methane detection. Those are the things that we kept hearing from customers that are constantly changing out there. And there was really no single platform to capture all those conditions around an asset. So we've heard of many different solutions where they'll have data in different kind of repositories or different stores that are dispersed across where they can't get to all of it to recognize the full risk of a particular asset. So this is one of the largest problems that we kept hearing from our customer base. And when you think about that also, not only are there issues that we're hearing around the siloing of data specific to the problems that could create a risk for assets, but there's also a regulatory component of that. And so I'll let Justin go into the regulation side of it here.
Yeah, I'm certain that everyone is familiar with how that sort of regulatory backdrop is probably been evolving. But PHMSA is increasing its attention more and more on natural force damage. In sort of PHMSA lingo, natural force damage includes things like earth movement, flooding, wind, lightning, thermal related incidents. So it's pretty wide ranging. Earth movement itself is a pretty broad category, but includes things like ground subsidence, landslide, sinkholes, faulting. Typically, you hear these referred to as geohazards. But really, this increased attention has taken the form through kind of different, really kind of various avenues. So the first obvious big one, the tie-in to mega rule, namely 72-hour rule around extreme weather or natural disasters, but also recent geohazard notices that PHMSA has put out in 2019, and then of course the update in 2022. And of course, we've seen also this sort of focus show up in their research investments too. So focused on expanding the state of the art and really the kind of applied engineering around these different types of threats, these natural threats. So Boston Geospatial has been a beneficiary of this, with its PHMSA sponsored efforts around geohazards. So a lot of that work is been funneled into this effort. We, like as Matt said, we spent a lot of time talking with operators, really trying to understand, given this sort of changing backdrop, what the ideal solution really looks like. And the answer, we think can best really be described as giving you, the operators the ability to go to a map of your assets, pick a point along the pipeline, and easily be able to tell regulators or other stakeholders everything that's going on there along with all the risks. So this is exactly what Irth and Boston Geospatial have built together with the pipeline integrity insight solution. And it's available as a standard app today in Irth. Matt, if you want to.
Great. Yeah, and let's drive more into what that solution is here. So when we go into the actual solution, from the problem that customers were telling us, again, remember, siloed data was the biggest problem across all these different geohazards that we have out there. So what we have put together is we put together, everything is driven by the asset itself. So we have this parent asset, which once we have the asset data, now we can do a bunch of processing off that data. So, we have an asset, and then what we do is we get alerts that actually come from satellites. So we're working with partners like Boston Geospatial and Justin here that have algorithms taking satellite imagery that detect things like methane on the ground, any type of seismic slope, fire, soil moisture, and then we're getting weather from NOAA here, which we'll show in a second. But all of those alerts basically come in now and link up to an asset if it's in a proximity to an asset. Now, what we're also doing is not only are we doing that, but we're actually creating a risk score for each one of the actual each one of the near real-time alerts that come in, and then you can see your risk across all the assets for all of your different variables. Well, the reason that that's important is because once we can auto fence and actually position it and say it correlates to this particular asset, and now here's what the risk is. Now we can have additional automation that kicks off, additional triggers that kick off, and those automation things can be everything from notifications that go out to team members, including supervisors or area managers to a higher level. We can automatically kick off things like work orders inside of our own product to dispatch field techs. Or we could also do things like actually integrating with like your main work order management system, like an SAP or IBM Maximo, to actually kick off corrective actions or additional work orders directly in those systems, right? So the solution, not only does it silo, but it creates the alerts that are near real time and then produces that risk result in real time as well. And then it creates the automation on top of it in real time. And that's where you get the biggest bang for the buck. So you don't have to just sit there staring at a screen all day long. The automation will kick off and take over there as well here. Now, with that said as well here, this is what the structure of what we've built together really looks like. So when you think about this here, there are many different data sources that we're getting kind of around the extremity, the far left-hand side and down underneath, the fire slope, seismic methane, the soil moisture as well. We've got the weather from NOAA all coming in. Inside of our system, inside of our solutions, we build a platform that stores the asset data, and then we can automatically correlate if a fire is linked to an asset, we can do that correlation directly in it, or if a slope is hitting an asset or seismic activity and so on. That's then where the risk logic also resides. We get additional risk logic in there that creates the risk for each one of those near real-time alerts. The 811 tickets that you see up above here at the very top, that's also another correlating event as well. We are the leader in 811 ticket management in terms of the number of tickets we have, the number of clients we have there. And not only can we see all of the external assets, weather-related geohazards, but now we can look to see if there's excavation activities in a similar area, right? So if you have an excavation activity with a methane plume with a fire, that's something that should be further looked into, right? And that's the type of data that we can correlate. And then, of course, what we can do with that, like we discussed earlier, is really kick off that work order, whether it's internal to our system or external to another system that you have, like a work order management system. All those different things can be automated. So when you think about why are we using satellite data? So we really have worked with customers on where is the data coming from. And when you think about where the data is coming from, you can see all the different data sources here, that we're showing. What we decided to do here, which we thought would be the biggest bang for the buck for the customers, is really focus on 2 points. The first one being coverage. So when you think about satellite, what we're doing with satellite now can look at your entire system, right? Your entire pipeline system, all of your segments within that system. And now you can get an idea of risk of where it's actually happening in near real time along the entire line, right? If you don't have that, you're doing manual driving, right? That takes time as well, and the cost can be pretty high of that. So the 2 variables that we looked at as the most important were the coverage aspect of giving a view of your entire system, along with low cost. And right now with satellite imagery, the cost has been driven down to a point where it's very optimal for this type of thing. So the market is really set for this. When you think about it in terms of like LiDAR produces great data, but still very costly. The cost of flying a plane, the cost of all the sensors on it, the cost of the pilot, very expensive. Same thing with dispatching field crews on site. You've got the truck rolls, then the resources there for that. So this is really what we're working toward, is really a high coverage, low cost offering, that you can see across your entire pipeline segments and systems. Now, when you think about the benefits of this here, there's multiple benefits. And I'll let Justin take over from here.
Yeah, so when we talk about remote sensing, really we're focused on this space-based remote sensing. So space-based remote sensing platforms, and in particular those that are in a low Earth orbit. So they're pretty close to the surface of the Earth. They're not way far out like a communication satellite or your like dish network satellites. Ones that are like really close to the Earth, they kind of go around the Earth every 1 to 2 hours. There's a lot of advantages those platforms have over ground-based or even airborne solutions. The most significant, as Matt said, is that coverage. So optical sensors, so like cameras, for example, radar sensors, they can image over 150 by 150 mile area all in like a single image in some cases. So you get this really, really, large area that you can cover. And when you put all that together, you can really cover an entire network spanning, the country, re, re, really easily. So, one of the obvious trade-offs is resolution. When you do that, when you have that ability to look over really large areas. But for a majority of the commercial kind of non-military intelligence applications, this is really not a concern. If you want to read the license plate on a car, it's very challenging. But you don't really need in a lot of these use cases that type of resolution to do these sort of threat detection. So that's the first really, really big advantage here, is just the coverage that you can provide is really large. The other big advantage of these platforms is the really high predictability of the revisit rate, right? So yeah, you can fly a plane to a certain area, but weather, logistics, all these things, time of day become a really big challenge. So with satellite platforms, there's very little change in, minus some, orbit changes and things like that. There's very little change in, it makes it highly predictable when you're going to revisit a specific place. So when you combine those two, first advantages by having multiple satellites, different types of satellites, you can in some cases get daily and in some cases get sub-daily revisits. So being able to take an image, every day or sometimes several times a day is what you can do by having that low Earth orbit platform, being able to look over a really large area and predictably going back to places on a routine basis. So another really big benefit of space-based sensors is that the platforms are very stable, right? Unlike an airborne platform, like an airplane, satellites don't experience turbulence, right? They don't go through these thermal drafts that impact imaging, which on aircrafts, for example, can make post-processing of imagery and even like, if you're working with radar data, for example, it makes it really challenging to post-process that imagery and use it for applications. So that's one of the really big, nice benefits of space, is that these platforms are highly stable. And lastly, the types of sensors we can put on satellites and that are on satellites today is really, really, really diverse. And it's getting even more diverse. Typically you go back 10 years and you maybe had a few radar satellites, but most of it was very coarse resolution optical cameras. Now we have hyperspectral cameras, which are kind of like a traditional camera, but take images over tons of different wavelengths. So you can detect methane plumes and you can detect, all kinds of different types of gases, specialty gases that might be leaking out of pipes. We have more advanced radar sensors now that can detect all sorts of terrain changes. So that diversity of the sensors is really increasing. Of course, radar is really cool to us at Boston Geospatial because it's actually the kind of our bread and butter when we first started out as a business. So we've really innovated in the radar space. Radar is really cool, just a quick plug, over optical sensors, because you can image at night. You can image through clouds and you can image through poor weather. So you can imagine, I have this great platform like satellites that can, revisit place really often, but what if there's clouds? And that's really the sweet spot with radar. Radar can see through the clouds, it can operate at night, and it can operate in adverse weather and give you that information about what's going on. So, and in a lot of cases, it can also be used to measure really small changes to the terrain at accuracies and sensitivities that are in a lot of cases better than LiDAR. So radar is a really cool, powerful technology. If you go to the next slide for me, Matt. So just as kind of a summary here, we have a growing list here of these threat capabilities in the standard app. And we're going to talk about that a little bit more in a minute, that leverage space-based radar, that leverage optical imaging, and with obviously more to come. We add new capabilities in things here on demand. And so we really rely on feedback and kind of that continuous conversation from all the end users like you. So if there's a certain thing, an application, a use case that you don't see and you're interested in, we don't cover it, let us know. We can do stuff really quickly, and we have done stuff really quickly. So, but really here, the key piece here is behind the scenes, there's a tech engine. And that engine is combining all these data sets, the satellite data sets, with some pretty advanced sort of cutting edge algorithms that are fully automated and are scalable too across really large areas, really worldwide. We also leverage a lot of digital twin modeling that takes things like elevation data, soil data, meteorological data to really understand that terrain risk, not just kind of like historically looking backwards, but also as time goes on and those conditions evolve and change. Okay. But the key piece here that we want to really emphasize is that, we handle all of this as well as all the threat detections. And then we really, synthesize all this into a very, very digestible insight, which gets routed, directly into your Earth environment to give you really best in class risk monitoring capabilities. So.
Right. Yeah, and with that said here, so there's a Q&A question already. So this is where the point where we get asked the most questions. So we have a Q&A at the very end of this. So feel free to write it in the chat here. We will make sure we address everything. You can also ask questions at the very end if you want to save them to the very end here as well. But we will address those questions. So going off of what Justin said, our goal here, if you think about Earth from a product management standpoint, is specifically here, we have to take a very complex process, very complex data and make it super digestible for the end user so they can understand it. And that's what we did here. And that's what we're actually showing on the screen. So, and I'm going to take some time to kind of explain this so you're fully aware of what this is here. Each row that you see here with the actual item IDs, that is an individual asset. That is a piece of segment of pipeline across the board here. And you can see the miles of pipeline that is, like 38, 8, 25, and so on, right? So each individual row is an actual pipeline. And then you actually have the columns, and those columns are the risk that we're talking about. So you've got a total fire risk and a highest fire risk. The reason for that is some clients like to have a view per quarter, where each quarter they look at their risk, right? And then it kind of resets quarterly with the number of assets, and then you get another quarterly view. Some like to do it by year, annually as well. The list does grow annually with all the risk if you do it annually, but that's okay. But what that does here is it gives you your total fire risk for that asset for a period of time, and then what is your highest, right? So you may have multiple fires along that asset, but they may be very small and not a real high risk. But then you may have one that is a fairly high risk, like you see here with that 55, right? So multiple fires, one fairly high risk with 55. Same type of thing with methane here. You get a total methane risk with the highest methane risk as well, same concept. Again, multiple methane leaks can happen, or multiple methane findings can happen along that asset. But what is your actual highest one? Same thing with the actual total seismic risk. So you can have a total and a highest seismic. Same thing with weather. What's our total weather risk along that asset? What's our highest weather risk? And then slope is handled a little bit differently, where we are looking at really what's your average slope risk versus your actual highest here. And the thing that's amazing about this, at any point in time, again, we're going for a coverage model across your entire segments, right? So if you have all of your pipeline segments loaded in here, you can come in here and just click on one of those columns to sort to see which one has the highest risk for whatever one of those variables you're looking at right there, right? So that is what we're talking about, the full coverage across, is seeing your highest risk between a period of time for each individual asset here. And that's what this screen does, right? So it helps you prioritize risk across assets and see those risks to get people on site to do corrective actions or mitigate them. So this is what we did from a view to take, again, really complex information, make it very, very digestible. And this is how we did it here. Now, with that said, there is an individual view, which is a much more detailed level view. And let me explain what that looks like here. This is what that much more detailed view looks like. When you click on that, you see all of your asset details, and you can go down into each individual risk itself, into fire, seismic, methane, pipeline, and see the individual details of what type of sensor found the device, when was that risk found, what are the flow rates of methane, like all that type of details displayed here. This is showing you from a graphic or from a geographical standpoint, from the actual map here. And what you'll see is that blue line is the center line of the actual asset itself. And around that, you see your risk. So we've got 3 fires that have taken place around that pipeline. Those are the big red kind of circles right there, where fires intersected with the pipeline. You've got your gray circles as well. Those gray circles are seismic activity. And then you've got, it's kind of hard to see because they're small, but there's these little pink kind of dots around. Those pink dots are actually polygons as you zoom in, which I'll show you here in a second a little bit more. But those are where your slopes are as well. If there was methane detected, you also see your methane deposit. I'll show you weather here in a little bit as well. But this is the view where you can see all of those risks along your individual pipeline segment. It is a real map where you can drill into each one. You can click on them from the map. You can get to the details of each individual one to say what was the risk of that single one. And how was it detected, date of detection, and so on, right? So very important to see it from a detailed standpoint. So not only do we have the summary screen that helps you prioritize risk, now you can drill into the details, see specific details here. And then this is even more of a detailed view. If I drill in even more, if you drill in even more, this is one of those slopes that I showed you prior, right? So that pink polygon is the actual slope. And now inside of that little pipeline buffer, you're seeing green, red, orange, and yellow kind of little polygons inside of that. That is the actual soil moisture. So when you look at the shape of that pink polygon kind of in the bottom left-hand corner, you'll see a bunch of red and yellow dots in there. Those red and yellow dots are bad because that means there's really high soil moisture content in that slope, which means that slope has potential to actually fall down, which could harm the asset here. So again, we have a view of a prioritization view from a summary screen, right? And by the way, you can export that data out as well directly from the system, which some clients do as well. Then you've got kind of that mid view of showing you your assets with all the risk, and then you can drill in to see the really individual risk details and get much more detailed view of what we have. Now, along with that, I'm kind of zooming out real fast because we didn't have a weather event that predicted that asset within a particular period of time, but we absolutely display any weather events in that particular area. And this is an example of a winter storm that happened here in California. But any of those weather events that intersect or are close to the actual asset, and by the way, you can set the distance from, is it 300 feet? Most clients do about 300 feet. Some like it to be much closer, 150 feet. It's really up to you in terms of how you want to correlate the data, right? The different detections that we have. But this is an example of that, right? And then these weather events not only can be attributed to your assets, but they can also go out specifically to individual field techs as well. So you're notifying them of any type of weather events that are occurring. So when you think about it, it's putting all the data together. If we've got, if this quarter we're looking at really a big zone of flooding, and then we've got a really bad slope in there, right? And then we take a look at, so those are the two predominant risks now. And then there was a seismic event that occurred, right? And that happened this quarter. Now you look into next quarter, and guess what happened next quarter? Now you see a methane plume where that occurred, where those risks occurred. And there may be an excavation activity right there. That's a bad sign where you may need to get someone on site to mitigate, right? But now you can do it beforehand. When you recognize beforehand, again, in one quarter, you've got flooding, bad slope, and seismic event. Now you can get someone on site before that methane plume even occurs now. And that's what we're trying to do with this particular solution here. Again, give you all the data in one spot. Okay. Now we go from a detailed view, what I've been showing you before, more detailed views on how you prioritize. Now you can kind of up level out in terms of your entire system, right? If it's around the entire United States or Canada or wherever your locations are here. But this is more of that macro view where you can set between a certain period of time to say, let's see all of the risk. And this is a heat map. As you drill in, the individual pieces break out to show you specifically, where they occur along, again, fire, seismic, slope, methane detection, weather events as well. And you can click on them to actually get to them from the map as well, if you want to see the more specific details about them. So our goal, again, was to take this very complex view, right? I mean, we're literally talking about taking satellite imagery and satellite data. We're talking about the algorithms off the satellite data, actually finding information, taking the data and creating information off of it. Now what we're doing is we're attributing that to actually analytics, which are risk now, predicting risk, right? And now that risk correlating together can be used in conjunction to stop events from occurring here, damages from occurring. So this is really the views that we have in here. And the very last part of this here is not only, again, are really those different views, but there's also a massive amount of automation that takes place after the fact. Again, notifications going out to whoever you choose in whatever format you choose, right? With the details of each individual risk in them. You set the thresholds, right? You could have it, you could have it go out just because a fire risk is so high, but maybe it doesn't come close to an asset, but you guys just want to be notified even. That's okay. Or maybe you only want like fire risk to go out if it is attached to an asset, right? That's a high risk. That's okay too. It really depends on each client. Each client does it differently. Not only, again, are there notifications out there, but you can set triggers and events to happen that create work orders directly in the system or pass the data via a webhook. And we also have an API where you can call in to get the data out, but to a larger system like a work order management system here for mitigation. And again, all those details will be passed over, where the events occur, the location of the events, the risk of the events, all a part of that. What asset it touches, all that data is there for you to digest in other systems and actually have mitigation activities for. So this is really the solution that brings it all together here. And now Justin's going to talk about the value of what we have here.
Yeah. So if we just kind of drill down into some of the data, natural threat related sort of incident data from PHMSA, which is all, it's out there. There's a big, I think it's like an Oracle database. You can go in there and see, you can cut it by all these different types of incidents. You can go look at, geographically, you can export the data and manipulate it. But if we just look at these sort of natural threat related incidents, and we actually go in a level further, and we specifically hone in just on earth movement related incidences. So again, earth movement in sort of in PHMSA lingo is really anything from kind of landslides to sinkholes, right? Typically are associated with geohazards. The average incident, for example, is for earth movement events is somewhere between $4 to $5 million of direct damage, right, to the pipeline. That excludes the lost revenue, excludes the downtime, excludes indirect damages to those impacted in the area. It excludes legal and regulatory costs and fines, right? You start adding those factors back in, and you're pretty quickly getting up past 10-15 million dollars on average per incident. So a lot of cost here. So really this, we take a step back and we look at this solution we walked through, this Earth pipeline integrity insight solution, and really it's going to help you reduce those costly damages. It's going to obviously help you improve that regulatory compliance piece. It's going to get you better uptime with your assets. It's going to really help you reduce emissions. We talked about the methane capability. It's going to help you it's going to really help you perform risk-based prioritization, right? Of your different activities. Matt touched on that a little bit, the different work tickets and items you have going on. And really that's going to help you drive down your costs, right? But it's also going to help you find things earlier, which we just sort of talked about, right? Finding things earlier is really important because we can obviously avoid the sort of spiraling of events and really catastrophic incidences, but we can also turn these sort of ad hoc operating expenses to fix these things. We can turn those into more looking like planned projects, right? We could turn something that's an ad hoc, operating expense into like something that looks more like a capital outlay, right? So that's going to obviously make your CFO really happy because your cost of capital is going to be much more efficient, right? And of course, I think that another big thing to drive home here is of course the optics around being proactive, using all this data, all this technology to improve these outcomes is really going to be meaningful to those external stakeholders. So.
All right, and then from the value standpoint, let's talk about the process, because I think when people hear that we're using satellite imagery, they initially think, oh, this is like a complex thing, a complex implementation. And the truth of the matter is it's not at all. It's actually very simple. We made it extremely simple to basically just be able to turn on. So this is really your change management process in a way, right? So the very first thing we do is we work with you on what variables you want to track. That's the very first thing. So not everyone wants all the variables. Some are concerned more about just weather and seismic events and methane. Some do want fire, some want all of it in there, right? So we work with you on the variables you want. We enable our Pipeline Integrity Insights app then, which gives you those variables. And then after that, you just import your assets, and we work with you on this. There's really three main ways to import your assets in the system. There's an upload for CSV or Excel files. You can do that and upload and import your assets in that way. You can import an actual shapefile in the system, which also works well as well. And then the third way is through an API. So we do expose an API where if you have another system, you can actually call and actually add in all of your asset data into the system as well here. So that's how your asset data gets in the system. Once that's done, then we are ready. We are ready. So I mean, it really is just passing the near real-time alerts and the threats intelligence to Earth via the API with Boston Geospatial and Justin. And so that data now comes in here, and what we're doing then is the system is automatically then correlating those real-time alerts to the correct assets, in real time here. And then you now have the ability to see the risk across your assets, and you can sort those risks really to see which ones have the largest environmental issue potentially, right? And so it really is a simple process to turn on and get implemented. And that's by design as well, because our goal was not only to, again, when we talk about like the coverage and cost, that was our massive goal there. And we were able to do that here and bring that down. Next goals are really to make it digestible, easy to understand with automation. And then really the last piece was to make the implementation as simple as possible. And so we've accomplished all of those things. which would be great for you guys to see when everyone starts using it here. So, and that's really it for our presentation here. So I think, we're on question mode right now. What I'm going to do first here, we've got 2 questions. So let's discuss those first here. And it says, so Justin, one question for you. One was just a comment. The other one is, how current real time is the geosatellite imagery? So
Yeah, sure. So it depends on which sensor, but for example, the radar can be as often as daily if we need to be, and can be, is less frequent as every 2 weeks, depending on the need. And that's for radar. For optical, same thing. You can get, if it needs to be, you can get down to intradaily now. So, having multiple images per day, provided cloud cover is not an issue. And that's fully tailorable beyond that. So if you only wanted pictures every year, so it's highly tailorable now. That this was not the case 5 years ago, 10 years ago, because there just wasn't a lot of these platforms up there. But this has really all changed. And the cost has come down, obviously, too. The latency, the time to get the images, to process them, to get them on the ground, all that's improved. So it's quite frequent. So, and again, it's tailorable.
Yeah, and then just to add on that a little bit, the weather data itself comes in as we get it from NOAA. So as NOAA updates the weather, we get that coming in from them in as real time as we can from them. So
Yep.
that's another component of that here.
Yeah,
Okay,
and some of the other data too that we use in this, like seismic data, that's all it's all real time. It's the latency is like, I think, a couple seconds maybe, for seismic events. So it's very, very fast.
Yep. Okay, great. And then are there any other questions that we have out there? Feel free to go off mute and just ask away here.
And I should add too, for fire, for example, for the fire detections, those are every minute. And the reason for that is because those use a combination of satellites in low Earth orbit as well as geostationary satellites. So there's the ability to do those fire detections much faster than, if you were just using low Earth orbit satellites. So it's a combination of both. So it's really a really great sort of collective here of different data sets that really open this up and allow us to do all these different things, different sensors. So that's a key piece of it. So,
Yep, great. All right. Any other questions here? And again, don't be shy. You feel free to write it in the chat or come off mute and just ask away here. Well, we might have addressed everything here at this particular point here. So I think we did such a good job. There are no more questions, Justin. Now, if you guys, if you have any questions, feel free to reach out to Earth on. I think it says they can't come off mute. Josh and Scott, are they able to come off mute, or is that a setting I have to hit somewhere? Oh, let's see. Mark, I'm trying. Give me a second to see if I can take you off mute. I don't know. Yeah, I don't think I can. Justin, do you see how to do that?
no, I don't have the power, Captain.
Okay, let's see. So Josh has said that you can't come off mute. Can you just type your question, even if it's long, and then we can reach out to you guys here. And by the way, you have our contact information here on the screen as well. So honestly, if there are questions, reach out to us and we will get those addressed, since you can't come off mute here. But what I'll do, I'll give you guys a minute to just start writing your questions and we'll answer those as they come in as well. So we've got, how sensitive is the imagery to detect and report excavators, bobcats sitting on or near the line?
Yeah, that can be done. It can be done with both optical and radar. You'll probably get a better image of what's going on with optical, given for the price, right? So there's a balance there of cost versus resolution. But yeah, what you can do kind of right away infractions with both sensors, optical and radar. They're both, Bobcat, an excavator, those things are gonna have a unique kind of fingerprint, if you will, in a radar image. Much like, visually seeing it, you'll, kind of notice it as a piece of equipment, right? Same thing with radar. There'll be like a return from that at that location.
Yeah, and Justin, this doesn't answer that question directly, but here's another thing I just thought about that, just to make everyone aware here. There are different offerings we provide using satellite imagery. So like example is we can also detect depth of cover. So across your entire segment. So in that case, would you provide us with lat and longs of where you've done like your manual or your ILI runs, and you provide us with those lat longs, we can point the satellites directly to the same lat longs to detect what the depth of cover is. And what we found is that the median and the mean is within 6 inches in terms of accuracy using satellite imagery. So that's another example of like how quality the data is.
That's a good example too of, like earlier we talked on, if you see something that we didn't mention you're interested in, that was one in particular that happened. There was a client that came and said, hey, we really need something that can, that we have more flexibility to be able to do the depth of cover surveys at an accuracy that is, within a certain level or better. Can you do this? And we went out, did a proof of concept, demonstrated it, and then operationalized it in less than 50 days.
Yeah, that's
Um,
great. Yeah.
and we can move quick. So don't be shy with the use cases, right? So
Yep. All right. So Justin, we do have a few more coming in here. So one of them says, I'm a patrol pilot, so observations I can see being pinpointed with accurate satellite imagery when reporting to the ground crews. So that's yeah, that is correct. And that's what Justin's talking about potentially seeing like the bobcats, the dozers, things like that here.
yeah.
Yeah.
I see Mark's question too about, patrolling. I don't think there's, a world where we ever would want to, not have aerial patrollers. I think that's an important role in the ecosystem, but I certainly think that there's, ways we can augment that patrolling activity, right? There's patrolling's really hard. We work with patrollers. It's a really, really hard job, right? It's very dangerous too, right? You're flying, you're trying to, fly the plane. Even with the spotter, you're trying to see certain things, right? There's some stuff you just can't see, right? You're not going to see, you might, if you're a trained geologist or you're a geophysicist, see scarping and understand that, oh, there's this slope's at risk for failure, right? But your average, aerial patrol pilot and spotter probably don't have that training. And those are the things that, our radar capabilities, our twinning stuff that's in the slope risk and in this application are going to help you with, right? They're going to augment the things that the patrollers can't see. And in some cases, tip off and help give patrollers things that they can see along the route and double check, right? So that's another thing too we haven't talked about here is what are these other sources of data that you're leveraging and you're using the platform, using Irth to collect, and how can we create like a feedback loop with those, right? So there's a lot of power, I think, to be in kind of harvested there between these different stakeholders using the platform, not just you as the end user, in integrity, for example, doing your integrity management activities, all the other folks in the field putting in data into the platform, doing their patrols, putting in markers for, anomalies they see, things like that. So there's a lot of, I think, power in combining these together to find and reduce these incidents and really collapse risk, right? So
Absolutely. Okay, great. Any other questions here? Feel free to write. And again, if you don't want to write, reach out to us, and you have our contact information here, and we will definitely respond to you. That is no problem at all here. So I'll give it another minute to see if we just have other questions coming in, and we'll. So, how is the depth of cover deprived? I may have missed that.
yeah, it's a good question. So for that particular application, what we're able to do is using radar, we can look at how terrain is changing over, say, a 1 month period, or typically you don't want to know that often. So maybe like every year you want to understand how has the terrain level changed in that area. So what we can do is with satellite radar, we can in some pretty complex processing that's again all behind the scenes automated, can look at how the elevation has changed at a specific point along the pipeline, and we can use that to help as basically create a proxy for how much is that elevation change maybe correlated to your depth of cover. So what we're measuring with radar is sort of how the elevation and terrain at a specific point has changed over some period of time. Ideally, you have to use that solution, you'd have previous depth of cover data, from, say a couple of years ago or whatever your last survey was. And what that'll help us do is it'll help us, instead of being able to give you a differential change in the elevation at a given point, we can give you a more absolute measure of it, right? And so what that helps us, we can, run that, and what we can show you is, hey, in this particular area where you're, cutting through a field, right, you've lost X amount of inches here of elevation, right? It's a proxy. It's not a direct measure of depth of cover. But what the benefit is allows you to see it, much more frequently than every couple of years at pretty good resolution, good enough for, for the sake of being able to kind of filter these out and find these areas and prioritize where you might go out and double check it manually, right, with a probe tool, or however you measure it to date. So, in the key piece here too is it's really economical too. So when we compare it to doing things like LiDAR, it's much more economical, and it's also more precise. So the real key advantage of radar is, we can get to accuracies and sensitivities that are much finer than LiDAR. LiDAR is great because it gives you tons of data spatially around, an area that you want to look at. But when you register it and you want an absolute, or even a differential change, you want to compare LiDAR for differential change, it's noisy. So radar is very sensitive. It allows us to look at millimeter, in some cases, millimeter level changes. You may not need that level of precision, but that's the type of precision that we can get out of those types of sensors. And we use it. That's what we use for the depth of cover application.
And let me also explain the depth of cover, because in case you said you may have missed it, we actually didn't talk at all really about depth of cover here. It is a part of pipeline integrity, but it's a different solution we have. And frankly, with all the questions, we should probably do another webinar, on that topic alone, because it is very similar, but just a little bit different. In that case, we are looking at individual points. And the amazing thing is that you can actually see when like tilling occurred, like in a farmland, and again, I will go back to accuracy of it, like literally our findings that were field tested on the ground after we produced the delta, the change in depth of cover from their initial readings to what we found with satellite, was a median in within 6 inches, and I think the mean was even within 5 inches, Justin. I think it was something like that, or I might have it switched, but extremely accurate for like satellite imagery here.
Yeah, we got well under the 6-inch mark. I think I'm trying to remember exactly, but it was somewhere around 3 or 4 inches, I think.
Yeah. We have another question specific to depth of cover. So how can you identify a pipeline in a congested corridor with other pipelines to get the correct depth of cover?
So that's a good question. I think the really, again, what we're measuring with that application is how the elevations change in a specific area, and then we're using that as a proxy to get depth of cover. So I think again, it's not an exact measure of your depth of cover, but it's helping you understand, mostly from human related change or even from natural processes too, where that elevation is shifted over time, either through soil and other things moving into place on top of it, raising the elevation, raising that effective depth of cover, or if you have areas that have been, for example, harvested, right? You got a plow went through it, ripped through it, tilled it, whatever, and you've lost maybe a couple inches there over, a year or two period of time, help you understand what that is. And again, it's a proxy, right? It's a proxy, but it's over a really, your large area. We can do it as often really as you want to do it, but conceivably you probably don't care any more than once a year or once a quarter. And again, it allows you to, take in even your previous data, look at these differential measurements, and then plan out where you think you need to go and actually manually measure it, right?
Yeah, and let me be clear with that too, because with the depth of cover that we have, instead of giving us an entire system, right, or a segment, you're actually giving us lat longs. Those lat longs were exact points of where you did some manual work to see what the depth of cover was, or like an ILI data came in at exact lat longs. So if you do give us a lat long that is directly in a corridor where you have another pipe on top of you, we Justin, correct me if I'm wrong, but we won't be able to see underneath to their pipe, correct? Right? It's
Right.
so mostly people are giving us lat longs where they actually have that data specifically. And then again, we're going for coverage with the depth of cover to say, in this area, like this lat long, the delta change was negative, 20 feet, which means it's closer to the ground level now. And that's where you focus now, right?
Right.
So that's what we're doing with depth of cover, but it does depend on where like the lat longs you provide with us first, because we have to have those first in order to get what that change in depth is here, that delta.
Yep.
Okay. And that's what we're doing there. Another question is, what is the maximum depth you would still be able to achieve accuracy?
I think again, it really has to do with, are you going to be able to come and provide, previous depth of cover measurements? Because that ultimately is going to impact, at least from the what we deployed for the customer we did it with. They were able to provide us past depth of cover data, and then after we gave our projections and estimates based on the change, they went out and redid those same points, hundreds of points, and we validated it in the field with actual probe tool measurements. So, accurate within a fraction of an inch was their in situ measurements. So we had a real truth to compare it to, right? So, there's not really the depth is really not an issue, because again, we're not measuring we're not measuring exactly the depth of the pipe. We're measuring how the elevation, how the terrain has changed above and around the pipe, and we can correlate that to the depth of cover, right?
Exactly.
So,
And by
there's
the way,
certain assumptions in doing that, by the way, right? But what we found in this particular case for this client, a lot of their pipe was in flat area, mostly around ag areas and some urban areas. The agreement was really, really good.
Yeah.
And it performed really well. So
absolutely. And the nice thing about what Justin's saying is once we have those initial lat longs with the elevation at those initial lat long readings, now we can actually just keep going with it as we go on. So because the satellite is so accurate here. We do have another question. It's around cost. What is the cost structure per mile, per license, or other? So what we do, we take a look at like how many miles of pipeline you want to run through this. There is also, we do look at like the satellite imagery in certain areas. There may be some satellites that are better imagery equipped, if it's really hilly terrain or mountainous terrain and just where they are, around the earth as well. But you'll be surprised because again, the cost of this imagery really has come down. Also, the frequency can have an impact on cost as well. The more frequent, that could mean some additional cost if we have to use a satellite that is, that costs a little bit more. But with that said, though, the imagery cost has really come down. So per mile, it's cheaper than even the manual side, going out and doing this work manually using a contractor. I think, I think the price that we've heard in the market, they do about, what is it, Justin, about 2 to 3 miles an hour of manual, like the contractors, and they were around 220 per mile, I think.
slow. And that assumes that you've already
Yeah.
done the legwork ahead of time
Yeah.
to get access to the land and
Yeah.
you
So
have
so the cost is actually cheaper than that. Our solution is cheaper than that cost here, as well here.
Yep.
So great questions. Okay,
And
awesome.
LiDAR and cheaper than LiDAR.
Yeah, that is
Which,
correct.
so that's another key piece here is the
Yeah.
cost and the time too. I mean, it's very timely to go talk with all the stakeholders. I mean, in this particular example that we talked about, there was literally over a 200-mile long pipeline,
Yeah.
hundreds of stakeholders that they would have had to, if they did the whole thing, go and facilitate, access to that. For the test points and the validating points, they only had to do it with, a few dozen, right? But that's a key piece of it too, is the time it takes to plan these things. So
Yep, absolutely. Okay, great. So I think that's all the questions. And again, if you have any interest or have additional questions, feel free to reach out to us. We're here for you to answer your questions. And really appreciate the time, really appreciate the feedback from everyone. It's been great. So look forward to next time here. And we'll probably have to do that depth of cover one next time here, which would be great. So look for that here and we'll talk to everyone then.
awesome.
Thank you, everyone. Have a great day.
Take care.